Hi everyone, happy Monday. We're gonna do today a little bit of looking at domain and range in real life situations. Now, this chart that we're gonna go over first may look pretty familiar to you guys. We did it the first day of algebra in your ninth grade year, and we did it the first day of algebra in your 10th grade year. But it's important to revisit it because it's going to help us for the couple of problems that we have to solve next. Okay? So let's go over our different types of numbers here. The first number we have is called a natural number or counting number. Now, I always say these are the numbers where if I were to say, hey, start counting, you would naturally start counting. So if I said start counting, you would go 1, 2, 3, 4, 5, 6, and so on and so forth. So 8 could be a natural number, 10, 100 could be a natural number. It's important to note that negatives are not natural. For example, when you start counting, you don't go -2, -1, 0. You naturally go to 1, 2, 3, 4, 5, so on and so forth. Okay. The next set of numbers are whole numbers. And I remember whole numbers because if you write out whole, 0 is right in the middle of that number or that word. So whole numbers start at 0. 0, 1, 2, 3, 4, 5, 6, so on and so forth. So 0 is an example of a whole number. 100 is an example of a whole number. 500 is an example of a whole number. Now remember, they could be in multiple sets. It could be a natural number and a whole number, just like 100. All right, let's jump to our next set here. Integers. We've talked a ton about integers over the past 2 years. Integers are all your positive and negative numbers that are not fractions or decimals. So something like -100, 0, 200 are all examples. -6.2 is not an integer. Negative 1.5 is not an integer. 4.5 is not an integer. It has to be a whole number, but it can be positive or negative. Now, these two we've done a lot of practice with, rational and irrational. Remember, rational numbers they could be fractions. They could have a decimal that ends, so something like 4.75. Or they have a decimal with a pattern, like 6.3333333, dot, 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 dot. Or it can just be a whole number, like -1. I guess that would actually be an integer, not a whole number, because whole numbers are not negative. An irrational number cannot be written as a fraction, does not have a decimal that ends, and does not have a decimal with a pattern. So something like 6.2513 dot 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 dot. There's no pattern to that. It's just a bunch of random numbers after the decimal point. Something like 4.27516 dot 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 dot. That is irrational because the decimal does not end. It does not repeat like that one does. Okay. And the most famous irrational number we've talked about is pi. 3.1415, and that's as much as I know, but it's a number that goes on and never repeats or ends. Okay, let's jump over to the next page and do 2 examples together. And then you have 5 to do on your own in the problem attic I posted on Classroom. So they like to ask questions like this. Which domain would be the most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in the household? Okay. So if we're talking about people in the household, think about your sets of numbers here. We have integers, which we know are positive and negatives. We have whole numbers, which start at 0 and go up like that. We have irrational numbers, which are just crazy decimals. And we have rational numbers, which can be fractions. So if we're talking about people, you can't have a fraction of a person or decimal 6.7234 ... of a person. We can't have negative people in the household, so it have to be whole numbers. We can have 0 people in the household, or 1 person, or 2 people, or 3, or 4, or 5, but it cannot be negative. So it would be choice 2 for that one. Okay. Number 2, it says an online company lets you download songs for 99 cents each after you have paid a $5 membership fee. Which domain would be the most appropriate to calculate the cost to download songs? So we're talking about songs here. Remember, rational numbers can be fractions. Oops. Whole numbers start at 0, but it says whole numbers greater than or equal to 1. Okay. Okay, whole numbers greater than or equal to 1. So it starts at, oops, starts at 1. You go up to 2. It can go to 3, 4, so on and so forth. Integers less than or equal to 0. So it starts at 0, and then it has to be less than 0. So -1, -2. Whole numbers less than or equal to 1. So 1, but then we have to go less than that. 0, -1, -2. I apologize for the squeaking in the background. Cooper has found a new toy that he has gotten a squeaker out of, so I apologize. So if we're talking about songs, you can't download 4/5 of a song or a fraction of a song. You can't download a negative song. That doesn't make sense. So it'd have to be whole numbers greater than or equal to 1. All right, guys. So now you're on your own. You're going to try 5 problems on your problematic. Use the chart on the front page of the notes to help you. Remember, if you get a 1, I will ask you to retry them. Typically, I only give you a 1 if you got pretty much all of it wrong. So give that a try. If you need help, let me know. Email me. And good luck.